Hello everybody, welcome to simulation of power electronics circuits using Matlab and SIMULINK. Power electronics is an application of solid-state elements to control and convert of electrical power with high efficiency. Power electronic converters can be divided into four groups. AC to DC converters, also known as rectifiers. DC to DC converters, also known as choppers. DC to AC converters, or called inverters, and AC to AC converters, or called cycloconverters. So converting the electrical energy from one form to other form with high efficiency is what is doing with the power electronics. But however, in order to test or design such systems in the real time with kind of a circuit boards and all these things, it will be really very difficult. And sometimes when you build all such applications in the real time, sometimes you feel, okay, this is not that good, we need to do something different. In that case, you want to modify the design, etc. But in order to rectify the situation, what we can do is use the computer simulation. Computer simulation is a tool to virtually investigate the behavior of the system under study. Computer simulation of power electronics can be very easy, safe, and cheap way to observe the behavior of the converters. That is the voltage of nodes, current at the branches, etc. And ensure that the converters does exactly what we need. Computer simulation also helps us to test our own ideas without wasting all time that we have built in breadboard or PCB boards, also known as printed circuit boards, just to find out whether this will work well or not. Matlab Simulink is one of the most powerful software for simulation of power electronic circuits. Matlab simulation or Simulink results are accurate and quite close to the laboratory measurements. When you want to simulate the power electronic converters with Matlab or Simulink, you can use all available in Simulink environment. This is very interesting property. For instance, you want to build a model which will convert the voltage from AC to DC, and you want to control the DC voltage. In order to control the DC voltage, and assume that the converter that we are using, which has the thyristor, and to control the DC voltage for a thyristor controlled rectifier, it is important to select the right firing angle. And this right firing angle can be calculated using the PI controller. And once we get the right firing angle from the PI controller, and that firing angle can pass to the pulse generation block, and from the pulse generation it fed to the rectifier thyristor modules. With that, you can able to get the controlled voltage. Now, in order to build such a complicated system where we need some kind of a controller, we can use some controllers like PID controller, fuzzy logic controller, or model predictive controller, and even there are the many kinds of control techniques are there, and you can even study those control techniques and build the controllers on your own. So this is one of the advantage of the Matlab Simulink, where you can use this Matlab Simulink and build your own model that suffice for your project. Cool. In the next lesson, we're going to start the Matlab Simulink and try to build a step response for a transfer function model. I will see you on that. Until then, happy learning.